Hey guys, this side Mayank, and this is the end-to-end MLOps project. The problem statement is to detect malicious URLs. Cyber criminals use various tactics to trick users into clicking on these URLs. Now let's jump to the technical stuff. Here you can see the architecture of the project. As you can see, we are using a dataset from MongoDB and have implemented CI/CD pipelines. I will explain more about that later. For now, let me show you the front end, which is the main part users will interact with. We have Streamlit as the front end with FastAPI for the API endpoints. This is the Streamlit app, which is accessible to users. Let me demonstrate how it works. I will start by entering a URL like google.com and click on predict. As you can see, the app identifies that the URL is safe to visit. Now, let me try with a malicious URL. I will copy it, paste it into the app and click on predict. As expected, the app detected it as unsafe. This shows that the app is working as intended. Let me also explain the backend a little bit. The data that I am using is in tabular format, and I have used a Python library called tldextract to extract key features from the URL for prediction. Now let me show you the FastAPI, which serves two main routes. Number one, the training route. Let's say we have to train the model with the new data. Then we can use the train route for the same. It is used to trigger the training pipeline. When the CI/CD pipeline would be working, the Airflow will run it every once a week. I will explain more about Airflow later. But here, we can directly trigger the training pipeline using FastAPI. Let me demonstrate the training pipeline. So I will click on try it out and then on execute. As you can see, the pipeline has been triggered. If we will check the logs, we can observe that all the processes are running in real time. One key point to highlight is that during the training process, artifacts and trained model are automatically pushed to the S3 bucket on AWS. So let me show you. Right now I am in the AWS console. Let me go to the S3 bucket. See the network security MLOps bucket. This is the bucket that I have created for the storage. Let's go inside it and you will find two folders, artifacts and save models. So the artifacts folder stores all the intermediate files from the training process, and the save model stores the trained model file, which is model.pickle, as you can see here. So this was the training route in FastAPI. Now let's explore the second route, which handles batch predictions. In the Streamlit app, I demonstrated single URL predictions where user could input one URL at a time to check its safety. But what if we need to predict the safety of a large number of URLs stored in a CSV file? That's where the batch prediction route comes into play. Here's how it works. So this is the batch prediction route. Let me click on try it out. As you can see, there is a file input option. So let's upload a CSV file containing multiple URLs. Then click on execute. As you can see, the response is generated in JSON format. You can also download the prediction as a JSON file for further analysis. So as you can see, this is a JSON output, which can be added to the Streamlit app so that we can store the data in a tabular format. So far, I have shown you the front end and the prediction interfaces. Now let's work our way backwards to understand how everything has been built. I will walk you through the architecture, tools, and pipeline that powers this entire system. Let's start by understanding the data behind this project. So, a URL contains various lexical features such as words, phrases, or patterns of characters. These features help us identify whether a URL is malicious or safe. For example, in the URL https google.com, HTTPS is the protocol. There are many other protocols like HTTP, which is without a S, FTP, SMTP, etc. Similarly, other parts of the URL contribute additional features that help in classification. So in my dataset, it consists of 30 key features which are extracted from the URLs. Here is the list of all the features. You can pause to read it. So here is the MongoDB dashboard. In the cluster, there is a database which is named as MLOps Network Security, and the collection inside it is called network data. As you can see in the network data collection, all the features are mentioned along with the target column that indicates whether the URL is malicious or safe. By understanding these features, we can see how each contributes to detecting and classifying URLs effectively. This forms the foundation of our machine learning pipeline and ensures that the model is trained on relevant and meaningful data. Now, let's move to the GitHub Actions and CI/CD workflow. So let's go to the Actions tab in the repo. As you can see, some pipelines have run successfully while others show errors. This is because the EC2 instance is currently turned off. I am using AWS EC2 instance as a self-hosted runner. Let's start the instance. Here we go, starting the AWS instance. Then I will click on connect and the instance is running. Now we will connect it to the GitHub Action by running the run.sh script in the CLI. And just like that, the runner is connected Now, let me go back to the GitHub Actions. Here is the workflow. Let's rerun all the jobs to demonstrate the CI/CD workflow in action. This might take 3 to 5 minutes to complete. Now you can see that the continuous integration, continuous delivery, and continuous deployment have all run successfully. Let's head to AWS ECR. The repo name here is my network Docker image. So this is a Docker image created by the workflow just now, and it will be pulled into the EC2 instance to run the container. Let me switch to the EC2 instance. Here, I am going to check whether the Docker container is running or not. For that, there is a command docker ps. Let me enter this command to see the containers which are running. And here it is, the container named network security is up and running as defined in the code. Now let me show you how Airflow is integrated into the workflow. So Airflow is running on the EC2 instance, accessible by a public URL. So let me open the URL, and as you can see, it is asking for username and password. The admin credentials are set in the Docker file, where you can see username and password. Both are admin. Let's go into the Airflow, write the username and password, and click on login. As you can see in the Airflow code, I have created two DAGs. The first one is network prediction. This is for the batch prediction, and the second one is network training for retraining the model. So in the Airflow UI, if you will scroll down, you will see two DAGs. Let's click on one of them, and you can see these DAGs are set to run on a weekly schedule, and there's a lot of information about the process. The Airflow is used to automate the entire pipeline. So let me manually trigger one of the pipeline. So I'm clicking on the start button, and now the DAG is running. You can see the graph view of the DAGs showing the flow of tasks in the pipeline and the processes which are running. The same can be seen in the prediction DAG. And I guess you have observed that this is not running locally. So the Airflow and all the processes are running on the cloud. This workflow ensures that the project is fully automated from training the model to making the predictions, and it's all managed through Airflow and CI/CD. So I have kept this explanation concise to focus on the most critical parts of the project. I hope you found this walkthrough informative. You can check the code in this GitHub repo URL. Thank you.